this table, right? Is that what you wanted work
Yeah.
help with? Okay. Does either graph pass through the origin? So what would it mean to pass through the origin?
Like 0, 0.
Very good. So can you see that the point for 0, 0, you look at your x coordinate and then look at either one of these are 0? That means that it goes through the origin. Got it. Y2 doesn't go through the origin. Y2 goes through the point 0, 2. So the y-intercept is 2. But this first one does go through the origin. So yes, y1. Got it?
Yep.
Where does each graph cross the y-axis? Well, crossing the y-axis means that x equals what?
0.
Yeah, x equals 0. So look to the right. Here's your x-axis. Here's your y-axis. To cross the place where it crosses the y-axis is where x equals 0. But y can be whatever, right? But x has to be 0. So this point right here would be 0, 3. This point down here would be -1, 0. I'm sorry, 0, -1. This point way down here would maybe be 0, -10. What's true about all of those points? The x coordinate is equal to 0. In fact, that's what this line is. That line is not y equals 0. That line is x equals 0. The y-axis is x equals 0. The x-axis is y equals 0. That makes sense? So where does x equal 0? Well, you can see it's right here. So it's 0, 0, and 0, 2. So this is y1, and that's y2. Got it? And when it says at what point do the two graphs intersect, we'll look at when y1 equals y2. Look for where those two y coordinates are equal to each other. And there might be more than one answer. Do you see where those are equal to each other?
X equals -2 and x equals 1.
Good. So the point would be -2 what?
-2, 4.
Good. And what would the other point be? You said 1, right?
Yeah. 1, 1.
So 1, 1. So those are your 2 points where they intersect. Okay. All right. Solve the system of equations. Have they taught you matrices yet?
No.
Okay.
Is that I've heard of it. Is that in the calculator?
Yeah.
Yeah. Can I go get my calculator real quick? It's in my car.
Yeah, sure.
Right.
Actually, you know what? You don't have to get it. I'll just show you how to do it.
Okay.
I'll pull up my calculator. You can just watch. Now, this is not really how they want you to do it, but it's definitely the easiest way to do it. So what you do is you take your calculator, and your first matrix is called your coefficient matrix. So I take all the coefficients. So 1, 0, 1, 1, 1, 2, 1, 2, 1. So I put all those coefficients here. Don't forget to hold the place with a 0 if necessary. You follow what I'm saying? You understand what I'm saying by that?
Yeah.
Okay. And then you've got the variable matrix, which is x, y, z. You actually don't have to put that in anywhere. I'm just showing you. And then you have the solution matrix, which is 8, 17, 16. You see where I came up with those?
Yeah.
So we're going to call that matrix B. So then all you have to do is you put these into your calculator. I'll show you how to do that. And then you basically are going to divide to solve for this, just kind of like a math equation, right? If I had A times X equals B. Now, what you would normally do is you would divide by A, right? Both sides. But you can't do that with matrices. There's no such thing as dividing in matrices. But what you can do is you can multiply by the inverse. You're going to multiply it by the inverse of that A matrix. And when you do that, you'll get the answer. Okay. So that's theoretically what we're doing. So now I'm going to show you how to do that. You go see where it says matrix to the right. It's like underneath the math button, the yellow, the orange underneath the math button. Do you see it?
The second button?
Yeah, the second button. So I'm going to name my A matrix. I'm going to edit my A matrix. So I go edit matrix, and you're going to have to put in three rows and 3 columns. So 3, enter 3. So see how it's a 3 by 3 matrix?
Yeah.
And then just literally plug in across 1, 0. I'm hitting enter. 1, enter, 0, enter. 1, enter. 1, enter. 1, enter. 2, enter. 1, enter. 2, enter. 1, enter. So there's my A matrix. Okay, and I'm done making it. Now let's do the same thing. Let's go back to matrix, second matrix, and let's edit. So I went over to edit. Let's edit the B matrix. And this B matrix is 3 rows by 1 column. Got it? So this is a 3 by 1 matrix, and this is a 3 by 3 matrix, just so you know. And I'm going to just type in 8, enter, 17, enter, 16, enter. Okay, and now let's quit. It's second mode, which is quit, and go back out. So now I'm going to type in A, and I'm going to type in A. So let me see if I actually can even do this with, do I have letters up here anywhere? I guess I don't have letters on this. So I'm going to go back to matrix, and I'm going to grab that A matrix, hit enter. And then you see this little sign I had to use. Look over to the left. You see that little inverse symbol? That's actually happens to be underneath the matrix button. So hit that, and then go back to your matrix and type in the B button. So you see what that's doing? It's multiplying the inverse of A by B. In other words, it's dividing B by A, which is kind of like how I would solve for X. Divide B by A. But I can't divide, I have to multiply by the inverse. And when I do that, whoops, I lost my matrix there somehow. Whoops, cancel. Second matrix B. When I hit enter, watch what it gives me. It tells me my matrix, my answer is 3, 4, 5. And remember what those were? X, Y, and Z.
Yeah.
So X equals 3, Y equals 4, and Z equals 5. So that's the easiest way to do these problems if they're allowing you to use a graphing calculator. Now, they might trick you, and they might ask you to like set it up or something like that, or they might ask you to show a couple steps first. So the other way to do this with the elimination is to try to take 2 of them, like just try to basically eliminate one of the variables using, so you can see that you've already eliminated, there's no Y in this. So why don't we eliminate the Y in these 2? That would be the best thing to do. Eliminate the Y. So I'm going to multiply this one by -2 to eliminate the Y. That would give me -2x minus 2y minus 4z equals -34. And then I don't have to change this one. I'm just going to write it underneath it so you can see. And now add those straight down. You get -x, those go away. -3z equals -18. Right? So now take this equation along with this equation and eliminate one of those. X plus z equals 8. I actually don't have to do anything to this because what's going to be eliminated when I add them?
The X.
That's right. Oh my gosh, well, -18. So add those down. I get -2z equals -10, which means z equals 5. Hey, look at that. Z equaled 5. Now I can go back and plug it in to find out what x equals. So if z equals 5, that means x equals, you can do that in your head, right? X equals 3. And I'll plug those both back into one of the other equations. Let's say x plus y plus 2z equals 17. Plug in 3 and plug in 5 to solve for z. or to solve for y, and you go y equals 4. So that would have been the other way to do it. That would have been the elimination way of doing it, which wasn't really that hard in that case, but you have to know what to do first, right? Since we have a y eliminated, that means that it's the easiest to eliminate the y in the other two equations and then combine them together.
Yeah.
Got it? But this
So-
method called matrix is really nice. It's a really nice thing to know how to do.
So if the y isn't eliminated, you just go back. So you have to do 2 then, right? You have to do-
Correct. Yep.
Yeah.
You'd have to double up. You'd have to do both. You'd have to do that with like these two, eliminate the y.
Simplified ones, right? And then that's
Correct.
Okay.
Yep. So it would just be a little bit more work.
All right.
Okay. Graph the solution set of the system. So notice this is a system of inequalities. I'm going to tell you right now, the easiest way to graph this when it's in standard form like this is to find the intercepts. So find your two intercepts, which means plug in 0 for x and then plug in 0 for y and solve for the other one. So can we do this in our head? If I plug in 0 for x,
Yep.
negative y equals 1. What does that mean I get for y?
-1 equals.
Very good. So negative 1. And then if I plug in 0 for y in this one, if I plug in 0 for y, what does x equal?
1.
Very good. So there are my 2 points, 0, -1, and 1, 0. You see how easy that was to do because it was in standard form? That was in my opinion, that's the best way to do it, because those are the 2 most important points anyway. If you're gonna have to graph 2 points, you might as well make them be the intercepts. And so you just have to connect them. You can see that the slope is 1 now, up 1 over 1. So, and you know that it's a dotted line. So do that, and then it goes down, down 1 over 1. And then now I have to just shade it in a certain direction. Well, I'm going to test the point 0, 0. Here's 0, 0, which is above the line, right? Is 0 minus 0 a solution to this inequality? 0 minus 0 is less than 1. Is that true?
Yep.
It is true, which means I shade it up. So I'm just going to shade my red graph up. All right. Now let's do the other one in, let's say, yellow. Can we see that okay? Or should I use blue? Blue would be better. Let's use blue. So let's do that same thing. Let's plug in, let's find the x-intercept and let's find the y-intercept. Actually, you know what? I'm going to use white. I think that'll show up nice. Yeah, there we go. Can you see that better?
Yeah.
So when I plug in 0 for x, 0 for x, solve that in your head.
Oh, 4.
Very good. Y equals 4. And when I plug in 0 for y, cross that out and solve that in your head. What's y or x equal?
6.
Very good. So 0, 4 is your y-intercept. And 6, 0, 1, 2, 3, 4, 5, 6 is your x-intercept. And when I graph that, so the slope is negative 2/3, right? So if I go down 4 and over 6, or up 4, 1, 2, 3, 4, and left 6, 1, 2, 3, 4, 5, 6. Just, it's sometimes good to put an extra dot down there, right? Whoops, didn't mean to do that, sorry. Making you sick. I'm trying to draw this line as good as possible. And notice this is going to be a solid line, right?
Yeah.
Now, which way should I shade that? Let's do that test point again. Is 0, 0 a solution for this? Is 0 plus 0 greater than or equal to 12?
No.
It is not. So where do I shade it?
Down.
No, down would have been toward that point. Remember, I tested 0, 0, which is the origin.
Oh, so you have to do it up.
Yeah. Yeah. So you have to shade it away from where that point was. That's right. So your answer is just where they intersect. So now I go through and I just erase all of those all those parts that were not part of it, or all the shading that wasn't part of it, and there's your answer. It's that region. Now you also might want to find where those points intersect. It looks like they intersect at 3,2, but let's make sure that works. If I plug in 3, 2, yeah, that worked there. 3, 2, oh yeah, that worked there too. Yeah, so they do intersect at 3, 2. If you draw it accurately enough, a lot of times you get lucky and you don't have to solve them by a system. Otherwise, you'd have to solve that by a system of equations, right? Elimination or whatever, because they might ask for that point. They might ask for this point, but we see that that point is 3, 2. We can see that. All right, good. Questions about that?
I'm just okay, so it's just you just plug in 0, 0, right, to get your stuff.
Yeah, so what I did is I plugged in 0, 0 as a test point. Now, if one of the lines went through 0, 0, you couldn't use that point as your test point, right? If one of the lines went through it, then you have to pick a different point to test. Just pick a point on one side or the other of each of the lines and test it to see if it works. Okay. Now, if the equation was written in slope-intercept form, or if you prefer to write that in slope-intercept form, then you can just shade it based upon the way the graph was. For example, if you wanted to take this equation, solve it for slope-intercept form, that would be 3y is greater than or equal to negative 2x plus 12. And then y is greater than or equal to negative 2/3 x plus 4. Do you see how I did that?
Yeah.
And to graph this one, which is, by the way, the same line, it's the same inequality as that one. It's just written in a different form. All you would do is start at your y-intercept 4 and go down 2 over 3, down 2 over 3, down 2 over 3. And then if you were doing it this way, do you see how the sign tells you that y is greater than or equal to?
Yeah.
So if this is your line, which one would be greater than in this case? This way or this way?
First way.
The first way. Do you understand what I'm saying? So if you're doing it this way, if it's in slope-intercept form, then you actually don't need to do a test point. Got it? But for some people, it's harder to put this in slope-intercept form than just to, find 2 points and be done with it. I can see either way. Either way is fine. So if you wanted to solve this one for y, I would just add y to both sides because it's a negative right now. So y plus 1, and now subtract 1 from both sides. Yeah. So x minus 1 is less than y, and now rewrite it so that y is on the left. Y is greater than x minus 1. So that's the same thing. You could have started at negative 1 and gone up 1 over 1 to find your next point, and then drawn your dotted line. And then you would know it says greater than, so it would be shaded, in this case, to the left, because that's above the line. This is below the line, less than. This is above the line or greater than. Okay, does that make sense?
Yep.
So either way, that whatever way you prefer is fine. All right, so this one looks a little tricky. I know it looks kind of weird, and you're like, what the heck? What do they want me to do here? Well, really what they want you to do, a different way of asking, like, what is x and what's y? But instead of asking you to find the solution x comma y, they want you just to subtract them. I know that's a weird way to ask it, but they want one number as your answer. Now, sometimes there's a different way to do this, but in this problem, for this example, all you're just really trying to do is solve for x and y and then plug them into that equation or that expression.
Yeah.
Okay. So to solve for it, first of all, notice whenever you see that you can divide something to make the equation easier, do it. What can I divide that entire equation by?
3.
Yeah. And when I do that, I'll get x equals 5 minus y, and that's a lot easier to deal with, isn't it?
Yep.
It's a lot easier to deal with than that other one. So now I can use substitution and I can plug this in for X up here. So 5 times at 5 minus Y equals, or plus Y equals 13. Now just distribute 25 minus 5Y plus Y equals 13. Combine like terms, that's negative 4Y. Subtract 25, that equals negative 12. So Y equals positive 3.
Yeah, and then just plug it back in.
Plug it back in, which means X equals what? You can do that in your head.
X equals 2.
2. And now plug in, what is X minus Y? 2 minus 3, which is
-1.
negative 1, exactly. And you might want to check to make sure, plug in this 2 and the 3 into here to make sure that was right. 2 and 3.
Yeah.
Yep, that works. 10 plus 3 is 13.